Okay, let's dive into this. We are looking at a seismic breaking news event that's literally shifting the open weight model landscape right beneath our feet. For the longest time, right, the absolute most powerful AI capabilities were completely locked up behind these walled gardens. But what we're seeing today, it's a fundamental transition. Open weight AI is officially having its Kubernetes moment. We're talking about moving from experimental playgrounds right into the hardcore production adjacent infrastructure. So in this explainer, we're going to break down exactly what this means for you, your code base, and your entire stack. Here's the roadmap for how we're going to tackle this transition together. We'll start with the open weight shift, then look at the 2013 Kubernetes parallel. From there, we'll hit the harsh reality of moving from an API to local weights, walk through a highly actionable developer workflow, and finally wrap up with some verified ecosystem tools. All right, part one, the open weight shift, frontier models go public. And this brilliantly illustrates how the barrier to entry for AI has just completely dropped. We're going from managing API quotas to simply dealing with hardware provisioning and license compliance. Just think about the lineup we're seeing right now. Z.ai just published GLM 5.2 under an MIT license, and it scored a massive 62.1% on SWE Bench Pro. Then you've got Moonshot announcing Kimi K3, matching closed frontier performance with a July 27th release date. And honestly, the biggest shocker, OpenAI just released their first open weight models since the GPT-2 era. I mean, wow. The entire dependency on proprietary APIs is effectively dead. Moving on to Section 2, the 2013 Kubernetes parallel, building the ecosystem. So to truly understand the magnitude of today's news, we kind of have to look back at 2013. That was the cloud-native shift driven by Apache Mesos and UC Berkeley's Ben Hindman. Back then, developers completely stopped relying on a single vendor's stack. Instead, they started composing systems from verified pieces, storage drivers, service discovery, network plugins. Well, today, we are at that exact same inflection point. Base models are no longer paywalled. We're transitioning directly into open tooling stacks, things like composed quantization pipelines and inference servers like VLM and TGI. The market is aggressively competing to build out an open tooling stack instead of just walling itself off. There's this quote from the source material that I absolutely love. It says, "That composition model is what turns a research artifact into infrastructure." Just think about that for a second. This is the exact moment AI becomes real, foundational infrastructure. It's no longer just some magic black box you ping with a prompt. It is a stack that you fully own, compose, and optimize yourself. Which brings us to Section 3, the API to local reality, the friction of self-hosting. Now, what's really interesting about this stat, that massive 62.1% SWE Bench Pro score for GLM 5.2, is that it's actually a bit of a red herring. Because with ownership comes responsibility, right? And honestly, a ton of technical friction. When you run weights locally, it exposes a massive amount of evaluation noise that those managed APIs were entirely hiding from you. The reality is that 62.1% does not translate linearly to your specific code base. Why? Because things like agent harnesses, prompt templates, and tool use configurations, they drastically alter the outputs. Your independent runs are going to diverge based entirely on your unique setup and your specific latency constraints. So yeah, don't expect those generic benchmark numbers to just magically save the day. And the friction isn't just in the outputs, actually. It's baked into the infrastructure itself. You're moving from this variable, pay-per-token model, where the backend is just magically handled for you, to a fixed GPU utilization model. Suddenly, things like memory fragmentation, KV cache limits, and cold start latency, those are entirely your problem now. You want to use quantization to reduce your VRAM requirements? Awesome. But you're going to have to eat the accuracy loss that comes right along with it. All right, Section 4, adapting your workflow, a developer playbook. So how exactly do we survive this transition? We've put together 5 absolutely critical steps for your playbook. First up, you have to pin your model versions and commit the manifest hashes. If you rely on latest tags, the weekly ecosystem updates will completely shatter your evaluation pipeline when dependencies drift. Step 2, validate your licenses right in the repo root. Step 3, build a custom local evaluation harness. Step 4, leverage managed fine-tuning pipelines. And finally, Step 5, containerize your inference. Let's double-click on Step 2 for a second, because I'm telling you, it is an absolute minefield. While GLM 5.2 is MIT licensed, which is great, it allows commercial use, many other models out there carry highly restrictive clauses. You really have to watch out for fabricated benchmarks and stale model names. Basically, always assume a license is restrictive until you personally verify it. Actually, I highly recommend checking out the curated GitHub list by Felix Zero called Awesome Open Weight Models. It exists specifically to help filter out all this dangerous hype. For step 4, you really want to leverage managed fine-tuning pipelines like AWS SageMaker AI. It fully supports open-weight customization for models like Qwen 2.5 Instruct across all the parameter sizes, 7B, 14B, 32B. It allows for SFT, DPO, RLAIF, and RLVR via LoRa. And the real beauty of this? You completely skip the total nightmare that is manual CUDA stack management while still getting highly reproducible training jobs. It's a game changer. And for step 5, containerize. You need to package the weights, the server, and our runtime dependencies into a single image using read-only mounts and isolated networks. And guys, this is a crucial security warning. Never, and I mean never, run unverified weights on your local machine with real credentials. You need to treat these models with the exact same zero-trust paranoia that you would use for any third-party executable. Which leads us nicely into Section 5. Verified tools and resources. Navigating the ecosystem. Look, this space is moving incredibly fast, so just finding reliable information is honestly half the battle. You should absolutely bookmark these right now. Hugging Face model cards are your best friend for primary license verification. Check out artificial analysis for independent evaluations of things like Kimi Key 3. Grab that Flex Zero GitHub list to dodge the hype. And honestly, if you want a literal masterclass in how this composition architecture actually works, go read the historical Mesosphere and DCOS stocks. I'm serious, the design patterns are virtually identical. So, the crucial point is that time is very much of the essence here. We are closely tracking the highly anticipated July 27th release of the Moonshot Kimi K3 weights. The clock is already ticking on this. In hour 1 of publication, you need to pin that commit hash immediately. And within 24 hours, get it running through your local evaluation harness. You absolutely must establish a baseline for your specific code base before the community forks start wildly diverging. The tools are open, the frontier weights are public, and this massive transition from simple API wrappers to true, robust local infrastructure is happening right now as we speak. It is such an incredible time to be building, but it absolutely requires serious engineering discipline. So, I'll leave you with this thought. Will your infrastructure actually be ready to securely establish a baseline before the community forks diverge? Get your harnesses ready, verify those licenses, and I'll catch you in the next explainer.